Okay, so this is a little bit more about work. We talked a little bit about this last week, okay? As far as we know so far, we've been talking about work or working as changing the energy of the system, okay? So if I do positive work or I add energy into the system, okay, that would be a positive work, or I can do work to take energy out of the system, which would be a negative work, okay? Work is based on the force applied through the distance. So kind of like those graphs that we looked at last week. Okay. So work is force times distance. And oftentimes you'll see it with this cosine theta attached. Okay. But basically what that means is that the force and the distance have to be parallel. Okay. Or anti-parallel, right? But along the same line, similar to how before, like when we did torque and they had to be perpendicular, okay, this one, they have to be parallel, okay, they have to be in the same direction. So if there's a force on an angle, then you only have to use the component, or you only can use the component that's in the same direction as the distance, okay, or it can be opposite of it, right, but along that same line, okay. If you, I don't really like this X, all right, so you also can find the work with an integral, okay? So kind of like how we did the area under the curve before. So if I take a force function based on distance, dx, okay, and evaluate it between two different positions, then I can also find the work, okay? Net work is based on net force, right? So if you have something that's applying a force in the same direction of motion, that will be adding energy to the system or doing positive work. And if there's something that the force is opposite the direction of motion or the displacement, then that's a negative work, taking energy out of the system. Okay, so that like nets out just like force. All right. Okay, so let's look at this one. Is positive or negative work done in these cases? Okay, so in part A, right, if my displacement is to the right and my force is up, right, that's a 90-degree angle. So that's going to be no work done, okay, because none of that force is in the direction of the displacement. All right, so that would be like, for example, if I'm thinking about carrying a tray of drinks across the room, okay, my hand pushing up on the drinks doesn't do any work on the drinks, right? They're not, they have the same energy they did before, because there's no, even though I'm moving with them horizontally, the force I'm applying is vertical. Okay. If they're in opposite directions, right, the work is going to be negative. That would be like a cosine 180. Okay. Here, if I look at these forces and I split into components, right, that one's not going to count, but that one will count. Okay. So that's also going to be a negative work because that's opposite the displacement. All right. And in this case, if I split that force, okay, this part of it isn't going to matter because the displacement is down, but that part will matter. So that will be a positive work because the force is in the same direction as the displacement. All right. So here's another little thing about just checking to make sure the displacement and the force are parallel. Okay, so you have to take that component. Again, it's almost always a cosine because that's almost always the angle that they give, but just be careful, right? Like, for example, in this part D up here, it wouldn't have been the cosine because it's in a different direction. Okay, so again, don't just blindly memorize stuff. Just think about what's happening, okay? You need the force to be in the same direction of the displacement, okay, or exactly opposite from it, okay? All right, how much work is done here? All right, again, this is going to be 0, right? Because if you think about it with the trig part, cosine 90 would be 0, okay? And since none of that's in the same direction, that's going to be a work of 0. And this is something that they really like to ask a lot. The centripetal force, okay, or whatever that tension or friction or what is pulling inward, is going to do no work, okay? Because that's always going to be perpendicular. That inward force and then the displacement at any moment, right, is along this path tangent. And those are going to be perpendicular. Okay, so any kind of centripetal force doesn't do any work on the object, okay, because they're perpendicular. Okay, all right, and then you can go ahead and do the examples on the next page.